Okay, today our topic of discussion is how to identify the given function is 1 1 or not. Okay, so what we'll be doing is we will see different rules which we have, followed by a small example. Okay, to understand the rule, then we'll come to the application part. Okay, so the first rule is based on the definition of 1 1 function, which is if f of x1 equals to f of x2 implies x1 equals to x2, where x1 comma x2 belongs to domain of the function, domain of f, then f is 1 1. Okay, this is the first rule. So what is the meaning of this rule? Means if image of two elements x1 and x2 are same, then the elements must be same. So which means two different elements should not have same image. Let us see with an example first. Okay, so if f of x is x square and f is from R to R, so if we do f of x1 equals to f of x2, we get x1 square is equals to x2 square, from where we get x1 equals to x2 or x1 equals to minus x2. So what does that mean? So image of x1 and image of x2 will be equal or will be same if x1 equals to x2, yeah, which is an obvious condition, right? If x1 and x2 are same, their images will be same. But we got an additional condition which is x1 equals to minus x2. Okay, so what does this mean? Like we are getting an additional condition. Let us understand this one. Okay, so what does this mean? So even if one element x1 is negative of second one, like if one is 2, other one is minus 2, then the images of both will be same, which is 4. So it won't be a 1 1. Okay, so what does this rule say is, so whenever you apply f of x1 equals to f of x2 for any function, we will see like which kind of functions you have to proceed with this rule. There are some more rules are there. Okay, when to apply what we'll see in time being. So first we'll just understand this one. So whenever you apply f of x1 equals to f of x2, other than x1 equals to x2, you get a different relation. Like it may be, in this case we got x1 equals to minus x2, it can be x1 equals to x2 plus 1, or x1 is equals to minus x2 plus 7, or it can be many different ways, root of x2. So whatever other relation if you get other than x1 equals to x2, then it means the function is not 1 1. I would like to add one more point here, that is sometimes you get a different relation, but you have to check is that relation valid or not, because we have this very important condition, that is both this x1 and x2 should belongs to the domain. So what if this relation will not hold in the domain itself? Like let us just see, if I take the same function f of x equals to x square, but right now this function is going from R plus to R, which means positive real numbers is the domain. So if I apply f of x1 equals to f of x2, so again I will get x1 equals to x2 and or x1 equals to minus x2. So but you see x1 x2 both must be in the domain. So if x1 x2 both are positive, this relation can't hold good, right? Because x1 plus x2 is equal to 0 is what we are getting. If x1 x2 both are positive, then this relation x1 plus x2 can't be 0, right? Okay, so we will not take this expression or relation between x1 and x2. It is invalid relation, so we should not take it. So f of x1 equals to f of x2 is resulting in only one relation between x1 and x2, which is x1 equals to x2. So we are not getting any other relation. We may get, but because you see this condition must be satisfied, both x1 and x2 must be in the domain of f. So with that condition we are ruling out this second relation which we get between x1 and x2. So this second example, this one is 1 1 and this one is not 1 1. Okay. So in the same way, like you have to like check, so whatever the second relation you get, whether it will satisfy this x1 x2 belongs to domain condition or not. Yeah, in this case it satisfies, because x1 x2 both are belongings to real numbers, and this relation is possible if x1 x2 is real numbers. But in this case we have domain as positive real numbers, so x1 and x2 can't be 0. Okay, so that's why we are removing this condition. So that is it with the first rule. Okay, now we'll go to the second rule. Okay, so what is the second rule is it more or less it is similar to the first one only. Okay, so it says if x1 is not equals to x2 implies f of x1 not equals to f of x2 for x1 comma x2 belongs to domain, then f is 1 1. Okay, so for problem solving we use the first one. Okay, so this I have just given this point because instead of directly giving as sometimes in the question they give, instead of giving the function f as 1 1, they may give some language which is like this, so which also implies f is 1 1. What does it say? If two elements in the domain are not equal, then the images should not be equal, that's all. Okay, so coming to the third rule, so basically we will use the first rule only for solving the problems. Okay, that is enough. So coming to the third rule, it is if f of x equals to k has more than one solution in domain of f, then f is many one, otherwise it will be 1 1. So what does it say? If f of x equals to k has more than one solution, so in the domain of f, so what it is saying is solution is nothing but the value which satisfies the equation. Okay, so if x1 comma x2 are the solutions to this equation, whichever it is given, f of x equals to k, that means f of x1 is equals to k and f of x2 is equals to k. So if x1 is not equals to x2, then it means this equation has two solutions, right? So if this equation has more than one solution, if this equation has more than one solution, I am taking, let's say, two solutions. It can have more than two solutions, 3 or whatever it is. So the first case, two solutions. If it has two solutions, then it means f of x1 is equals to f of x2, right? Because f of x1, f of x2 both are k, which means f of x1 equals to f of x2. Okay, so if x1 is not equals to x2, that's why we are saying two solutions for this equation, right? So if x1 is not equals to x2, but f of x1 is equals to f of x, this whatever rule we have spoken, it is getting failed. So that's why we are saying it, this function will be 1 1. So here what we are saying, if there are two different elements, they should have two different images, but here x1 x2 are different, but they are having same images, right? Okay, so that's why it is many one. Okay, so we'll see just one or two examples. Okay, so let us say f of x is x square plus 1 by x. Let's see. Now is this function 1 1 or not? Okay, so we are trying to do this question using this rule, right? Yes or no? Okay, what I will do is, let's set f of x equals to 3 will do. Okay, and again this is very important, domain. If it is R to R, then we are solving. And again understand, we are just doing these examples to understand this rule, that's all. Okay, where are we? So let us solve the equation f of x equals to 3. X square plus 1 is equals to 3x. We get x square minus 3x plus 1 equal to 0. Discriminant is positive. You will have two solutions, alpha and beta. So since we are getting two solutions, so it means according to this rule, if f of x equals to k has more than one solution, then f is many one, right? Because yeah, the lead is from this second rule. Because alpha is not equals to beta, discriminant is positive, not 0, and f of alpha is equals to f of beta, right? So which means two different elements are having same images, so which means it is not 1 1. Okay. uh, Now if there is a doubt like why I have taken only 3, why not 4, 5, see, it's just intuition, and it comes with practice. Because I have chosen 3 because 3 will give me more than one. 3 will, because you have to just foresee the next expression which is coming, right? So just one expression which you have to do the calculation inside yourself, then I think it will be clear. Okay, so whatever expression, so we'll see some more question. Let's say f of x is second example, x square plus 3x minus 1 by x square plus x plus 11. Okay, so f is from r to r, so we have to check whether this function is 1 1 or not. You see, straight away I can say this function is not 1 1 because if I make this, if you observe the numerator, no? This has two roots. So if I solve f of x equal to 0, this expression x square plus 3x minus 1 equal to 0, because denominator will go right side. So I'll get two roots, alpha and beta, where alpha is not equals to beta, but f of alpha and f of beta both are same and it is equal to 0. So which is not 1 1. So basically it is just through practice you get which one you should take. So if you are not getting this idea, no problem, we have another method which is there. So but in some problems we get to think in this direction to solve the question faster. Okay, so coming to the next rule. Okay, very simple rule, which is if f is always increasing or always decreasing in its domain, then f is 1 1. Okay, so how to check whether a function is always increasing or always decreasing is by drawing the wavy curve. Okay, wavy curve of f dash. So first we'll see small question first. Okay, then we'll proceed. First f of x equals to x plus 3 by 2x minus 1, let's say, and f is a function from all real numbers minus half. I should remove because at half it should not define, to r is there. So let's say the definition of function is this. Now I have to check whether f is 1 1 or not. So how to check whether a function is always increasing or always decreasing? So how to check is by using the derivative test. So whenever f dash is greater than 0, so it implies f is increasing. Whenever f dash is less than 0, it implies f is decreasing. So here in this question, so if I do f dash of x, I will get u dash v minus u ad minus bc, because it is of the form ax plus b by cx plus d. Derivative is minus 7 by 2x minus 1 whole square, which is always negative, correct? So f dash is always negative, so function is always decreasing. So does it mean f is 1 1? Because our rule is if f is always increasing or always decreasing in the domain, then f is 1 1. So does this mean because f is always decreasing, does it mean f is 1 1? Yeah, but there is one more observation which you have to do, which is whether the f is continuous or not. Okay. Yeah, there are functions which are always increasing or always decreasing in its domain, but still they may not be 1 1. Okay. For example, if I have a function which looks something like this, let's say, or it may be going to infinity, then again it is starting, it looks something like this. If you look at this function is always increasing in domain. It is increasing from let's say 0 to a is not in domain, and also from a to b, let's say up to b, this is there. So it's always increasing, but it is not 1 1, because there are, because if we go to this rule, if f of x equals to k has more than one solution, then f is 1 1. So if I draw a horizontal line which is y equals to k, so if this x coordinate is alpha, this x coordinate is beta, this point coordinates will be alpha comma f of alpha, and this point coordinates is alpha comma f of beta comma f of beta. F of alpha, f of beta, both are k. So and alpha beta are not equal, but f of alpha is equals to f of beta. So which means it is not 1 1. Okay. So we call this test as horizontal line test, which means if I draw the graph of f of x and if I draw a horizontal line, if it intersects, if the horizontal line intersects the graph of f of x at more than one point, then we say function is not 1 1. Okay. So you can see the reason why. If the horizontal line intersects at 2 points, it means at these two x coordinates the y coordinate is same, right? So that is f of alpha and f of, why I am writing f alpha comma f of alpha is there is a point on the graph of f of x. So y coordinate we will write it as if x coordinate is x, y coordinate is f of x. So alpha f of alpha, beta f of beta, and both f of alpha and f of beta must be k, because it is on the line y equals to k. So if a horizontal line intersects at more than one point, it means those two x coordinate will have same image. Okay. So which means not 1 1. So you can see here this function f of x is always increasing, right? Increasing, and here also it is increasing, but still f is not 1 1. Okay. So be careful in applying this rule. So where you should be careful, so not only you have to check whether f is always increasing or always decreasing, make sure that this kind of thing doesn't happen. Okay. And when will this happen? This kind of scenario will happen whenever the function is discontinuous. Okay. So we will see this f of x is, so coming back to the question, now there is a doubt whether this function, whether it is 1 1 or not, right? So if I look at here, f of x is x plus 3 by 2x minus 1, I got f dash as always negative, but this function is discontinuous, right, at x equals to half. That's why even though the function is always decreasing, this function is always decreasing, right now we are not able to say confidently whether this is a 1 1 function or not. Why we are not able to say it is confidently it is 1 1 or not? Because even if the function is always increasing, in this case it was not 1 1, right, because of discontinuity. So this function is also discontinuous at half. So even in this case we can't say it may be not 1 1. So let us see, okay, how to check whether it is 1 1 or not. Okay, x plus 3 by 2x minus 1. So f of x equals to x plus 3 by 2x minus 1. So if you know how to draw the graph of this function, then yeah, well and good. So draw the graph of this function and then see whether any horizontal line intersects this function at more than one point, then your answer will be done. Okay. So that is your graph method. Okay. So which is fifth one. So I think yeah, fifth one, which is graph method. So which is a little off topic, like we can't be discussing about graphs when the topic is testing 1 1. So if you know the graph of any function, you just draw it. Okay, so we can discuss that later, how to draw the graphs and get a grip on drawing the graphs, but right now this is not the point of discussion. Okay, so what I want to say is, if you know how to draw the graph of this function, you draw the function and then you check whether the horizontal line intersects at more than one point or not. Okay, coming back to the discussion. So this rule, whichever is there, is not so we are not able to verify, right? Okay, with this rule. So why? Because this function is discontinuous at half. So be careful, you apply this rule only when this function f of x is continuous, or you can apply even if it is discontinuous, but you should have you should be careful in that case. Okay, you should be able to to draw the graph of this function and then conclude, not just by seeing whether f dash is positive or negative. Okay, so if that is not there, then how, let us see. Okay, so f of x equals to x plus 3 by 2x minus 1. So if f of x equals to k, if I solve this equation, okay, I get x plus 3 is equals to 2xk minus k. So which is x into 1 minus 2k is equals to minus k minus 3. I will get x is equals to k plus 3 by 2k minus 1. So no matter what value of k you put, other than half, you put whatever, because if k is half, then x will be undefined. Okay, other than half, no matter which value of k you put, this equation f of x equals to k is going to have only one solution, right? You are not getting any quadratic or anything like that. You are getting only, you put one value of k, you get only one value of x, right? So coming to this rule, which is what does it say? If f of x equals to k has more than one solution, then f is many one. But can f of x equals to k have more than one solution in this case? No. No matter what is the value of k, f of x equals to k, always you will get exactly one solution. So you will never get more than one solution. So therefore in this case f is 1 1. Okay, now, okay, so these are the 5 rules which you have. So now let us next we'll discuss about the problems related to these rules. Okay, let us solve some questions now that we have seen the rules for identifying a function to be 1 1 or not. Okay, the first question, very basic one, you will see f of x equals to mod x, and f is from R to R. So is this function 1 1 or not? Okay, so that is what we have to find. So I think the graph is very simple in this case. So this is mod x graph. So horizontal line intersects at more than one point. It is not 1 1. Okay. So coming to the next question, f of x equals to x mod x. Okay. So again, if you are having difficulty in drawing this graph, then we'll see f of x equals to minus x square if x is less than 0, because mod x will be minus x if x is less than 0, x square if x is more than 0, and when it is 0 you can put equal to 0 here or there, anywhere, doesn't matter. Okay, so for this function, for less than 0 you have to draw minus x square graph. Okay, so which is like this. For more than 0 it is x square graph. Okay, so if you draw a horizontal line anywhere, it intersects the graph only once, so it is 1 1. So what I want to say is, if you can draw the graph of any function, so go ahead, draw it. So that's the best easiest way. Okay, if you can draw the graph, you just you can see whether the horizontal line intersects more than once or not. Okay, so that is the first thing, okay, point which I want to say. Second, Now if the function is complicated, we can't draw the graph. So let's say f of x is x square plus 3x plus 5 by 3x square minus x plus 7. Now how to proceed in this case? Okay, so again remember the rules which we have. Okay, one is f of x1 equals to f of x2 rule. So if I try to proceed using this rule for this problem, you can see there will be too many calculations, right? So x1 square 3x1 plus 5, all this right side, the same expression with x2, you have to cross multiply, simplification. Yeah, it's a big task. Okay, and so that is one rule. So we are not going to use this rule. Okay, second rule we have is f of x equals to k1, and other one is increasing decreasing, and next is graph anyway we can't draw, so that's why we are looking at these four rules. So f of x equals to k, and other one is f is increasing or decreasing rule. Okay, so right now we have these two. Okay, so can I use the increasing or and decreasing rule? Yes, because this function is always continuous and denominator is never going to be 0 because discriminant is negative for the denominator. So it is always a continuous function. Okay, so this is continuous, f by g is continuous and g is not equal to 0. So therefore f by g is continuous, this whatever the given function. Okay, so I think we can go ahead with this rule because we just need to differentiate, that's all. Okay, so whenever a function is continuous, you can go ahead with the derivative rule, increasing and decreasing. To be precise, I should be saying differentiable function, but anyway. Okay, so first we look at the continuous functions. Okay, f dash. So if I do f dash of x, already I have done the calculations for this question. So we get something like minus 2 times 5x square plus 8x minus 13 divided by 3x square minus x plus 7 whole square. Process is easy, only you do by using u by v rule. Okay, so if you look at f dash, this function, so anyway this should be mentioned, f is from r to r, let's say. Okay, so f dash is this expression. Okay, now what we have to verify is whether this expression is always positive or it is always negative. But in this case you can see this is quadratic, which is, so the denominator is always square, it is always positive, and there is minus 2 always negative, but this expression changes the sign. Are you getting? Because this expression will have two roots, alpha and beta. So if x is more than beta, then this value will be positive, because quadratic graph, you know, opening upwards graph will look something like this. So more than the larger root, the value of the function will be positive. In between the roots, the value of the function will be negative. Okay, so between alpha and beta, this value will be negative, negative into negative positive, positive by positive, overall f dash will be positive. Okay, more than beta negative, here negative. So you can see that the function is not always decreasing or always decreasing. So therefore this function is not 1 1. So we were looking at this question. So we have solved it using the derivative method, right? Okay, because the function was is not discontinuous. So we solved it using the derivative method, and we got the function not always increasing or not always decreasing. Okay, so if this function would have been 1 1, then we would have got wavy curve to be always positive or always negative. Okay, not something like this. Okay, now we had two methods to choose, like f of x equals to k, and the choosing of k is intuitively you have to think and you have to choose k, and then the other method, right? We have done by this method. Now we will see, we will try to do using this method. Okay, f of x equals to k. So what is the rule? If for some k, if f of x equals to k will have more than one solution, it has many one. Okay, so x square plus 3x plus 5 divided by 3x square minus x plus 7. So first thing, is first looking at this, if I equate it to 0, like in this question, which question? Yeah, like in this question, if we equate it to 0, in this question, if we equate it to 0, we got two roots, right? Because numerator is equal to 0 has two roots. But right now in this question, 0 will not give. The first thinking will be equal to 0, simple, because does it go to 0 at more than 1 point? It is not happening. Next, let's take half. Why I am interested in half is, after cross multiplication, x square coefficient will come 1. Just it's just a try based on luck, that's all. Okay, we will see what happens if I equate to 1, 2 or something like that. First we'll equate it to half. I'll get 2x square plus 6x plus 10 is equals to 3x square minus x plus 7. So we got x square minus 7x minus 3 equal to 0. Yeah, discriminant greater than 0. So this function for two different values, alpha and beta, will give output as half. Okay, that is what is understood. And what is that alpha and beta? They are the roots of this equation. Okay, we were lucky enough to get that by trying with half. Okay, so in majority of these kind of questions, quadratic by quadratic or quadratic by linear or whatever it is equals to k, you try to follow this f of x equals to k method, because in the most of the k values you will get this discriminant greater than 0. You can try for k equals to 1. If I substitute take k equals to 1, then I will get x square plus 3x plus 5 for k equals to 1 equals to 3x square minus x plus 7. So which will give me 2x square minus 4x plus 2 equal to 0, which is x square minus 2x plus 1 equal to 0. So we are getting only one root, right? One solution. So with this you can't conclude. So even if you get this, you can't say it is 1 1. Are you getting? So the point is, if the graph of a function is something like this, let's say. Now there are some lines, horizontal lines, which intersects the graph of the function only once, but there are some lines which intersect twice. Because there are some lines which are intersecting once, that doesn't mean the function is 1 1. Okay, if there exists even one line which intersects this graph twice, then it is 1 1. Sorry, then it is not 1 1. Okay, so here also f of x equals to, see, we have seen the relation between what is the relation between solutions to f of x equals to k and drawing a horizontal lines like this. Okay, the number of solutions to f of x equals to k will be nothing but number of intersections of the line y equals to k and the graph y equals to f of x. Okay, so in this case, that horizontal line, which is that horizontal line, y equals to 1, because we have taken k equals to 1. In this case, the line y equals to 1 is intersecting this graph at one point. Okay, that doesn't mean it is 1 1. So for k equals to half, the so let's say for some other value, it is intersecting at 2 points, right? Yes or not? There are two values, alpha and beta, where the output of f, this is the output of f, equals to half. We have done the reverse way. When is the output half? For two values at alpha and beta, both the output is how much? Half. So the point will be half comma alpha comma half and beta comma half. Okay, so you try to look for k such that this whatever the resulting equation, you will get two roots. Okay, and we were looking in this case that half or something like that. If we are lucky enough, we will get in the first go itself, but you keep trying, because after substituting equals to k, you always get a quadratic, right? Okay, so quadratic normally, if you adjust the k properly, you will get a quadratic where you will get two roots. If you get the two roots, then yeah, then the given function is many one. Okay, So there comes one more question, that is, sir, what if this given function, I tried half, I tried 1, I tried 2, 3, 4, whatever it is, what if I am unlucky and every time I am getting only one root or no roots? Okay, so maybe the quadratic may have one root or no root, right, or two roots is another possibility. What if I am never getting this two roots possibility? So then will I be able to say it is 1 1 or not? Still the answer is no. So in that case what you have to do is then proceed with the derivative test. Okay, so don't keep substituting the values of k and keep checking. Okay, so maybe looking at it at the first glance, if you can intuitively with practice you will understand. Okay, if you can take some value of k such that this equation are getting two roots, then it's fine. Okay, okay. So in some questions, like in this question, the choice of k was little straightforward and easy, because you try 0, you are getting this function to be 0 at two different values alpha and beta, so it is not 1 1. But in some cases like this it is not that easy. Okay, so whenever you come across questions like this, don't waste much time in keep substituting the values of k and checking and getting lost in that process. If you are not successful in one or two items, you can go ahead and try the derivative method. Okay, so this choice of k is just you can substitute and you can check. Okay, so if you are lucky enough, then you will get it in the first go, otherwise not. Okay, so coming to the next question. Okay, f from -2 to infinity to r, f of x equals to x square plus 2x plus 7. Is this function 1 1 or not? Okay, again whatever methods you have, x1, f of x1 equals to f of x2, you can all those are there, but here you see why I will choose the derivative method is this function is continuous, right? And if you understand the meaning of differentiability, then this function is differentiable also, then we will go for derivative method. Okay, right now don't think much, this function is continuous, so we are going for derivative method. Okay, so how to apply the derivative method? You just need to draw the wavy curve for f dash. So what is f dash of x in this case? 2x plus 2, which is 2 times x plus 1. Always draw the wavy curve in the domain of f. So now the domain is -2 to infinity. So to draw the wavy curve, first you have to mark the zeros of f dash. What are the zeros of f dash? When is it 0? -1. Yeah, it is in this domain, and after -1 it is positive, here negative. So you can see the derivative is not always positive or not always negative. So therefore this function is not 1 1. Okay, coming to the same, so we will keep the function same, but we will change the domain. Like let's say the domain is 0 to infinity to r, and the function is x square plus 2x plus 7, same function. Okay, so what is f dash now? 2x plus 2, so again it is 2 times x plus 1. But now for the wavy curve, whatever number line you draw only the domain, right? 0 to infinity. So in the domain, is f dash 0? No. So we are not going to mark any point on the number line, this wavy curve. Okay, so if you are not marking any point, there won't be any sign change. So in this part, what is the sign? You just see more than 0, f dash is always positive, it will be positive. So that means f dash is always positive, so f is always increasing. So if f is always increasing in the domain, then the function is 1 1, so f is 1 1. Alright, okay. Let us take another similar example. Let us say it is f of x is equals to x cube plus 3x plus 5. F is a function from R to R. Domain is R. Okay. So again, it is a continuous function. So let's go with f dash. So f dash is 3x square plus 3. So which is 3 times x square plus 1. So you can see f dash is always positive, right? No matter what is the value of x, f dash is always positive, which means f is always increasing, and if f is always increasing, function is 1 1. So if you are having a doubt why if f is always increasing, function is 1 1, and you see if it is increasing and continuous, it is 1 1. Be careful, again I am stressing on the point continuity. Okay, so only if the function is continuous you will go for derivative test. Okay, otherwise not. So in this case, x cube plus 3x plus 5, you see the function is always increasing like this. So whenever you draw a horizontal line, it will only intersect once. Okay, so that's why if a function is always increasing or always decreasing, we say it's 1 1. Okay, let us take another example. F of x equals to x cube plus x square plus 3x plus sin x. Is this function 1 1 or not? F from R to R. Let us see f dash. What is f dash here? 3x square plus 2x plus 3 plus cos x. Okay. Now, if I look at this quadratic expression, its minimum will be when x is equals to minus 1 by 3. So when x is minus 1 by 3, the value of this function will be 1 by 3 minus 2 by 3 plus 3, which is 3 minus 1 by 3, 8 by 3. So f dash of x is equals to cos x plus this expression, and this expression is always greater than 8 by 3. So this expression is always more than 8 by 3, no matter what is the value of x. If this expression is always more than 8 by 3, cos x plus this expression is always going to be positive, no matter what is the value of x, because cos x, the least value of cos x is minus 1. So even in the worst case, this f dash is still positive. Okay, it can never be negative. Okay, so f dash is always greater than 0 for all x belongs to R. So therefore this function is 1 1. Okay, so let us see another function. F of x equals to e power minus of x square minus 3x plus 2, and f is a function from minus infinity to minus 1, sorry, plus 1 union 0 to e power 5. Okay, now we'll see this function. Again, let us use derivative rule. What is f dash of x? It is e power minus of x square minus 3x plus 2 into 2x minus 3. Okay, so let us in the domain minus infinity to 1, we will draw the wavy curve. So when is it 0? 3 by 2. 3 by 2 is not in the domain. So whenever x is less than 1, this quantity is always negative, and no matter what is the value of x, this value is going to be always positive. So the product of these two expressions will be always negative. So which means f dash is always less than 0. So f will be 1 1, this function, in whatever domain they have given. Okay, let us come to another question. F of x is equals to x square minus 4 by x square plus 1. F is from R to R. Is this function 1 1 or not? Okay, I think it doesn't take much time. I can say directly this function is not 1 1. Why, tell me? I didn't use derivative test, nothing. You see, this function will be f of x will be equal to 0 at x equals to 2 comma minus 2. You remember that f of x equals to k rule. Then you can apply it here. Okay, so equal to 0 at 2n minus 2. So 2n minus 2 both will map to 0. Okay, because the value of the function is 0 at 2 as well as minus 2. Okay, so it is not 1 1. Okay, next example. F of x is equals to, sorry, not f of x, f of n is equals to n minus 1 by 2 if n is odd, minus n by 2 if n is even. F is a function from natural numbers to integers. Is this function 1 1 or not? Okay, so you can see here the domain of the function is not continuous. Okay, so you can't use the rules of differentiation here. Okay, differentiation is normally used when the domain is continuous, right? Now here we can't use because the points are discrete, the function is defined discretely. Okay, so whenever you have a domain which is not continuous, okay, you use you try to do using the mapping diagram. Okay, so let us say natural numbers 1 will map to which element? If I look at here, 1 minus 1 is 0. Okay, 2 2 is even, so minus 2 by 2, 2 will map to minus 1. 3 3 will map to 3 minus 1 by 2, 1. 4 4 will map to minus n by 2, so which is minus 2. 5 will map to 2. So I think we are getting a pattern here. 6 will map to minus 3, 7 will map to 3 here, like that. Okay, so you can see always the distance between the mapping points is increasing. Okay, if we are proceeding, so I think it is safe to say that this function f is 1 1. Okay, next, f of x equals to, so now I am discussing about those questions where we are not using the derivative rule and f of x equals to k rule. Okay, so that category questions I am discussing. Okay, just to have an idea about this one. Okay, so let us take f of x equals to x plus 1 if x is rational, x plus 3 if x is irrational. Is f of x 1 1 or not? First we will understand the function. What will be f of 1 here? It is 2, because 1 is rational, so we will substitute here. What will be f of root 2? It will be root 2 plus 3. Root 2 is irrational, so we have to substitute here. Okay, so just understanding is, if the input is rational, it will be x plus 1, irrational then x plus 3. Okay, then how to check 1 1 for this function? So we can't differentiate because the function is changing a lot. You see, at rational it is one function, irrational it is another function. Okay, derivative is not defined for this kind of function definitions where the domain definition is not continuous. Okay, so we will see like so how to approach. In the domain, let us say I have two elements x1 x2. Remember the first definition, if x1 is not equals to x2, that should imply f of x1 not equals to f of x2. Okay, or if x1 x2 are two elements, if f of x1 equals to f of x2, that should imply x1 equals to f x2. If you remember, that should be the only outcome. If this comes out, then yeah, we can say it is 1 1, otherwise not. Okay, so we will take 3 cases here. Okay, why we have to take 3 cases? Because 3 combinations are possible of x1 and x2. That is case 1, x1 comma x2 both rational. So in that case, f of x1 will be x1 plus 1 and f of x2 will be x2, f of x2 will be x2 plus 1. So we are getting only one rule, x1 equals to x2, right? So therefore if x1 x2 both are rational, then this function is 1 1, like if the domain is only rational. Okay, so another possibility is there, that is x1 x2 both irrational. Okay, so if x1 comma x2 both are irrational, then f of x1 equals to f of x2. What does it imply? We will see. If x1 is irrational and x2 is f of x1 will be x1 plus 3 is equals to x2 plus 3. This is also implying x1 equals to x2. So whenever we get this only one rule, then we will say it is 1 1. Yeah. Okay, and next case 3, if x1 is rational but x2 is irrational. Okay, so one is rational, one is irrational. So f of x1 equals to f of x2 will give us f of x1 is x1 plus 1, f of x2 is x2 plus 3, right? So because x2 is irrational, so we'll get x1 is equals to x2 plus 2. So we are getting a different relation other than x1 equals to x2. But remember here what we have told. So if yeah, this is the rule. If just a second. Yeah, the rule is this. If f of x1 equals to f of x2 implies x1 equals to x2, but x1 x2 should belongs to domain. See, in this question f of x equals to x square r plus, if you remember properly, we got a different relation between x1 and x2, but still this function was 1 1. Why? You have to check this condition. Is it possible with this relation both x1 x2 belongs to domain or not? Okay, is it possible that x1 x2 both belongs to domain and that relation will be valid? Okay, let us check here. So we got this relation, but this x1 x2 both should belongs to domain. Okay, and we have taken one as rational, one is irrational. So x1 minus x2 equals to 2 is what we got. So x1 is rational, one is rational, one is irrational. The difference is 2. Is it possible? No. Rational minus irrational can't be 2. So you can't take this relation and say it is not 1 1. Okay, because this relation can't hold at all. Okay, so the two cases, so in this case f of x1 equals to f of x2 is only possible if again, like x1 equals to x2 is not possible because one is x1, one is rational, one is irrational. So what is the conclusion here? F of x1 and f of x2 can't be equal because these two cannot be equal. These two cannot be equal because this can't be 2. Are you getting? So one rational element and one irrational element, if I take, the images can't be same. If I take both irrational, still images can't be same. If I take both rational, still images can't be same. Images will be only same if both are same, but if both are different, images can't be same. So this kind of relation will not come in this function. This function will be 1 1. Now what we'll do is we'll change this function little bit and then we'll see. Okay, let's say f of x is equals to x plus 1 if x is rational and x plus root 2 if x is irrational. Okay, so again if there are two elements x1 and x2, if f of x1 equals to f of x2, it should imply that x1 equals to x2. That is what we are looking for. Okay, so first case again, case 1, if x1 x2 both are rational numbers, then f of x1, which is x1 plus 1 is equals to x2 plus 2 1, will give us x1 equals to x2. Fine. Case 2, x1 comma x2 both are irrational numbers, will give again x1 plus root 2 is equals to x2 plus root 2. We will again get x1 equals to x2. Fine. Okay, so which means if the domain has only rational numbers, then it will be 1 1, because if x1 x2 both are rational, this is not possible because images are same implies both are equal. Okay, same thing if the domain is completely irrational. Yes, okay, that is it. What if one is rational, one is irrational? So that means x1 is rational and x2 is irrational. In that case, if I do f of x1 equals to f of x2, I will get x1 plus 1 is equals to x2 plus root 2. So x1 minus x2 is equals to root 2 minus 1. I got some relation between x1 and x2. Now I just need to check whether does this relation hold such that x1 x2 both belongs to, will satisfy this, should satisfy this condition whatever we have given, and they should belong to the domain. Okay, is it possible? We'll see. X1 is rational, x2 is irrational. Okay, one is rational, one is irrational. Subtraction must be this. Rational minus irrational can be irrational. Yes, very much possible. Like for example, if I take x1 as 1, let's say, then I will get x2 as 2 minus root 2. x1 is rational, x2 is irrational, and this relation is holding, because rational minus irrational can be irrational. That relation is very much, yeah, it is possible. So we'll see f of x1 equals to 1, x2. So x1 and x2 are not equal, right? What will be f of x1? F of x1 is nothing but x1 is rational, so it will be 1 plus 1, x plus 1. Okay, let's see. If x is rational, it is x plus 1, otherwise x plus root 2. 1 plus 1, we are getting 2. What will be f of x2? It is x2 plus root 2, which is again 2 minus root 2 plus root 2, which is again 2. So which means 1 as well as 2 minus root 2, both are mapping to 2. So it is not 1 1. So you can see here both are similar questions, right? The before one and this one. So what was the only difference in this two questions? Here there was root 2, there it is 3. But what made that 3 and root 2 a lot difference in both the problems is the relation. This relation cannot be possible, but this relation is possible. So always whenever you are using this f of x1 equals to f of x2 rule, you please check whether the whatever the different relation you get other than x1 equals to x2, will it be valid or not. Okay.